All right. This first part will be same number and types of questions as will be on the final in the short answer part. So my first job here is going to be to graph each of these. Now if it's been a little while since you graphed, struggle with graphing, we can get you set with this. Whenever I'm going to graph, I'm always going to take care of the y-intercept first. Okay, whatever number's sitting here on the end. So for this first one, I'm going to go ahead and use my black pen. So if my y-intercept is 1, I put a big old dot on the y-axis where that 1's going to be. As far as figuring out the slope from there, remember, we like slope to be a fraction. So if it isn't 1, I'm going to make it 1 by putting it over 1. So if my slope here is 2 over 1, what does that mean as far as where I go? In this case, since they're both positive, it means I'm going to go up 2 and right 1. So I'm going to go up 2 and right 1, up 2 and right 1. And if I run out of room, which is a possibility sometimes, I can do the opposites of both of those. And go down 2 and left 1. Down 2 and left 1. Because I want to have dots all the way through my graph. Yep, I put the 2 over 1 because I always want slope to be a fraction. So once I've done that for my first one, I go back, and I'm going to use a different color, at least for me on my second. Oh, no, thank you. So what's my y-intercept going to be for my second line? What number's hanging out on the end by itself? 4.
Hey, wait, what? This is down 2, left 1. Why is it that?
Okay, so when I was back on this one originally, when I plotted my points. Oh, geez, I'm sorry.
He's not here.
And he's not here. That's okay. So I'd made my original 3 points, but I wanted to make points all the way through my graph. So I looked and I'm like, well, what can I do? Because when I started here with my y-intercept and then went up 2 and right 1, well, I kind of ran out of room. So if I wanted to be able to go the other way, I can do opposites of both of these. So I can also go down 2 and left 1 from that same point, and I end up on the same line. It lets me make dots all the way through, is what it does. And we're going to do that again on this one. So when I get here, this time, my y-intercept we said was 4. Okay, so there's my big dot. But all I see is a negative sitting in front of the x. So what's that mean? What's my slope going to be if I just see a negative? Yeah, it just means I'm putting 1s with both of those. So my slope here would be negative 1 over 1. Or in other words, I'm going to go down 1 and right 1. So down 1, right 1, and there is the point where they're going to intercept. Now, I could keep going down 1, right 1 if I wanted to. Okay. But my whole goal is to find that one spot where both lines have the same point, same intersection. So once I see that, I just got to write down what that point is. Right 1 and up 3. So my answer is 1, 3. And I'm done. I'm good. Okay. So any graphing questions are always going to work that way. Okay. Now, we might switch up methods. Now we're looking at substitution. Now, normally when we look at substitution, we're going to find out that x or y is alone. X or y is by itself. So once I find one of the equations, oh, here's y by itself. Okay. I'm going to box in what's on the other side. And since that says y equals, that's right, I'm going to substitute it in where the y is at. So here's how this works. I got 6x plus 3. It's just the y that it replaces. So I say goodbye to the y, cross it out, and replace it with what's in the box. Everything else, absolutely. Everything else in my equation stays the same. So you'll notice from here to here, the only difference is the y went away, and what's in my box replaced it. And exactly, once I get here, I'm going to do my distributing first because I need to get rid of the parentheses so I can solve this. All right. And then make sure that you distribute your 3 not only to the x, but to the 3 as well. If you happen to have any like terms. And the only reason I can get away with this is these are on the same side of the equals. If they're on opposite sides, we'd have to take a little different way of going after it. But right, because at this point, I need to get my x by itself. And now it's just like a regular old equation like from first semester. And divide by 9, since I'm multiplying by 9 here. And I get my x. Now we're not quite done yet. Exactly. Here, I've figured out what x is. But to figure out y, it's a much shorter process. Because if I take, that top equation, and now I'm replacing the x value, I have y equals my x value, which we just found out is -1, so I'll replace that, plus 3, so y equals 2. And I get my answer that way. But the one thing I will stress here is when we do get into the final and stuff, you're still going to have to be able to show steps of the method. This isn't going to be able to be one if I do have the numbers that come out nicely like this. You can't just sit there and play guess and check the whole time. Because I need to see that you can do the method. Because sometimes you may get a fractional answer and you won't be able to do that. So just something to consider a little bit. Yep, and this one turns out nice because now we're using the elimination method, which normally means we just want to add down and see if something cancels out. And sometimes we're going to get lucky. So here I've got 1x and 1x is 2x, okay. Positive 1y plus negative 1y cancels. Awesome. That's why it's called elimination. And 6 plus 4 is 10. And right, all I've got to do is take this one-step equation and I will get my x value. But again, I'm not quite done. I always like to take my top equation then. Yep, I'm going to replace the 5 in for x. I don't know what the y is, so that's what I've got to find. And I'll get my y value. And similar to what we were saying in number 2, okay, again, you've got to use the method in order to get there. Now, will elimination always work that easy? Not necessarily. Unfortunately, no. Sometimes if I try to add down, oops, my x's don't go away and neither do my y's. Okay. Yep, I've got options here. I can either, if I wanted to get rid of the x's, if this is 2, I'd like this to be -2 because 2 and -2 would cancel. I could multiply by -2. Or if I look at the y's and I'm like, well, this is already a minus. If this is 3, I'd like this to be -3. So let's just say we see that and we like to deal with the positives instead. So we decide we're going to multiply by 3. That first equation has nothing done to it.
Sorry, how did you get that 3 from the 3y?
For here?
Yeah,
Because here's what's going to happen. I decided, I'm like, okay, if I wanted to get rid of the y's, this is a positive 3y. I'd like this to be -3y because then they'd cancel out when I add. So since this is already negative, if I multiply it by 3, and I do that all the way through down here, now when I go to add down, positive 3 and -3 cancels, and I can have it go away. And I could have done that with x as well.
I thought you had the time with the topic.
It doesn't always have to be the top. It can be either. And then I'm just going to add down. And again, we're back to a quick one-step equation. Since we're multiplying by 5, we'll just divide by 5. And I'll get my x value this time first. And you don't have to get x first every time. Sometimes it can be y. And then you have your choice on which equation you want to plug into. It doesn't matter. Now, this may seem strange to some of you. I'd actually plug into the top one. I hate dealing with the negatives. So if I was going to do that, I'd be like, all right, 2 times x, but I know what x is. X is 2. Okay, the only part I'm replacing is the variable. Everything else stays the same. And this time I got an extra step. Multiply my 2 and my 2. Get the 4 out of there. So 3y would equal 9, and then I'll just divide by 3. But like we'd said before, if you would have multiplied both by -2 at the start, that would have worked too. We just gotten the answers in the opposite order. But I will absolutely do some things for points when we get down to the days before the final. If people want to turn these in when we're done with them, I'm good with that. And again, we're way back. I mean, this is like beginning of the semester type stuff we're looking at here right now with these. So, what's that?
We're just doing a review right now.
Yeah, we're strictly going into review mode here. Trying to make sure that all that stuff that we haven't seen in a few months kind of gets refreshed into our minds here again. So, all right, when we flip over, let's see what we got. You've started your own lawn mowing business. Your cost to buy equipment and advertising was $320. If every lawn costs $8 for gas and oil, holy cow, those are some big lawns, and you charge $12 for mowing each lawn, how many lawns must you mow before you break even? Okay, so $320, okay, that's my cost before I start up. So then, let's see. Plus, because that was a one-time cost, I don't have to do that all the time. Every lawn that I do costs me 8 times the number of lawns I do. So if I only did 2 lawns, I'd plug in 2 for x. If I did 10 lawns, I'd plug in 10 for x. And then that's going to equal what I'm making or what I'm charging, which is $12 times every lawn that I mow. Now, if somebody can think of a shortcut for this, which there is, you might be able to quicken this up by a step. But this time, here's what's a little different on this one from what we were doing the last one. Are my x's on the same side of the equals this time? No. Okay, so yeah, it would probably be in our best interest here to minus the 8x over, because this side just has x's right now anyway. And what would my last step be? Divide by 4, and we find out I'm going to be mowing a whole lot of lawns before I break even. I need to charge more or find some cheaper gas. But yeah, there will be some things with break even or just kind of setting up. Again, we did a little bit of that before too. Now this next one, this is the newest stuff. Yep, on both sides, once I see that radical, I'm going to use the squared to get rid of it on this side. But again, whatever I do to one side, I have to do to both, just like I do with any equation. What's 6 squared? 36. So once I get here, my goal now becomes to work on getting that x by itself. So I'll minus that 4 and then just divide by 2. But again, all of these things are just processes that we're dealing with. And like I said, some of them are newer, some of them not quite so much.
I did. The substitute tried making me Josh and Andrew go do it.
Oh.
She tried to-
Yeah, I feel like you guys had to go. Like,
Oh, geez. Yeah, that's not quite the way I'd written it, but all right. So then when we're doing division with, whenever we divide with exponents, we're going to subtract big minus small, and the answer goes with the bigger exponent. Now, I could, if I wanted to, okay? Then again, this is with the exponents. It isn't 10 minus 5, it's 10 divided by 5. Which goes 2, right, because 10 is bigger than 5, so the 2 is going to go on top. And then if I remember the rule, 8 minus 2 is 6, but the 6 goes on top because 8's bigger, and right. 5 minus 2 is 3, but the 3 goes on the bottom because that's where the larger exponent's at. Now let's say you're like, I'm not going to remember this. You know, what am I supposed to do then? Here's your option. As long as you can figure the 2 part out, you could, if you wanted to, knowing that the 2 is going to be here, you could physically write out the variable portions like this and just say, okay, so those y's cancel, those x's cancel, and then just count them up. 1, 2, 3, 4, 5, 6x. 1, 2, 3, y. Okay?
Why'd you have to do that counting thing?
You don't have to. I'm just saying in case sometimes when you're taking a final exam, you'll forget a rule with something because there's so many to keep track of. So if you happen to forget on the exponents, that's a backup plan that you might have just in case. Here, if I have negative exponents, they need to get flipped. You're like, wait a minute, flipped? Okay, remember, anything I do is always in a fraction mode. So here, the 3 still has a positive exponent. It gets to stay on top. But since the A and the B both have negative exponents, they flip downstairs, and there they become positive. No other work to do. I just have to remember that those flip. And that's it.
The degree is all
The degree is the biggest exponent on one term.
That's 5.
So it's going to be 5. And that's it.
Next.
Wish they were all going that quick, right? And then this one looks real complex, like one you might think about skipping, but don't, because it's really not that complex. So you're like, all right, researchers studied the number of overnight stays in this park campground in the backcountry over a 5-year period. Okay, modeled these results. What polynomial models the total number of overnight stays in both? This is a really fancy way of saying add down. Okay, a very complicated way of saying something very simple. So here, and look at, they're even lined up for me already with like terms. I don't have to do anything fancy here. So negative 7.1 plus 21 is 13.9. I keep my x squared. Don't change the variables at all. Negative 180 plus negative 140.
Now you add.
Yeah, we're adding. Be careful. And then 5,800 plus 1,900. This would be the representation of a way I could get the total number of stays. Okay. So if you see something that looks crazy and huge like that, just add down. Just combine like terms. Okay. Keep life simple. Simple is good in so many ways.
I don't like to play like.
Well, and unfortunately, sometimes, and especially on the short answer, they just show up. But here's the nice thing with the word problems. You're always given the formula that you're supposed to use to plug the numbers into. So on Monday, Jill had $80 in her account. Tuesday she had 40. Wednesday she had 20. If this pattern continues, write a rule for the nth term of the geometric sequence. Now here's what that means. Okay, this is staying a to the n. That first part's not going to change. A to the 1 is just, how much money she started with. How much money did she start with?
80.
Okay, she started with 80 bucks.
Wait, why is it N more?
I'll explain that part in just a second here. Now, R is going to be your rate of increase or decrease. So how much, okay, right, and that's the thing that's interesting, because you're like, well, the first day it looks like it went down 40, then went down 20, so it's not like a specific number, and that's true. So if you're going from 80 to 40 to 20, what's happening each time? I'm cutting it in half, right?
0.5.
0.5 or 1/2. So this R, I could call 0.5 or I could use the 1/2. And then that just stays n minus 1. Okay, any place you see an n stays n, because we're just looking to write the rule down. I'm not looking for a specific amount, not looking for a specific time. I'm just trying to say, if I came up to you now and said, how much money is she going to have left on day 15, you could pop the 15 in there for the n and get the answer.
So that's what we do.
That's all you've got to do on that one. When it says write a rule, that's the rule. Basically, it means write an equation and just plug in the numbers that you have. Now this one we actually get to do an answer for. Bought a new computer for $3,500 in 2005. Whew. The computer depreciates at a rate of 18% per year. What's the value of the computer 3 years after you bought it? Okay. A is always going to be the amount I start with. 1 minus. Now, R stands for rate. My rate is 18%, so do I just put 18 in for R? No. I need to do its decimal equivalent, which means I take the 18 and I divide it by 100. So I'm going to use 0.18. And then T is time,
3.
and that's 3 years.
Can we just plug that into a calculator?
And we're just going to plug that in. So let me get that out of the way. So 3,500. And again, a lot of these questions, if you can get the initial setup going, calculator can do all the work. So after 3 years, that computer is going to be worth $1,929.79. Ouch, the price of technology.
And but we not to
So yep, definitely want to go with the nearest cent, because we're not going to go up to somebody and say, hi, it's $1,929 and yeah, 78.8 cents. Yeah, probably not. So that's how we're going to end up dealing with that guy. 13. Use foil or the box. Now, with a 2x3, I'm really going to push the box here because it's going to organize all my like terms too. So the side that always got 2 boxes, I'm going to put the x and the plus 5. And the side with 3, x squared minus 7x plus 12. And again, I got 1s as exponents on these. When I'm filling the box, I'm multiplying. So I'm adding exponents. So x, or x to the first, times x to the second is x cubed. Minus 7, x times x is x squared. Yeah. Plus 12x. And multiply those. So nothing fancy here. 5x squared. 5 times negative 7 is negative 35x. And 5 times 12 is 60. And here's what I meant by the box organizes everything for you. Yep. All right. If I start in the upper left corner, there's my thirds. There's both my x to the seconds. Again, we're just combining like terms now. So if I got $5, oh, I went and spent 7. I'm 2 in the hole. Notice I didn't change my exponent, only when you're filling the box. Negative 35 and 12 is negative 23x. And the plus 60 is just there on the end. So it does all the organizing for me. I just got to make sure I've got things in good shape and off way out.
Left to right then?
Yep. Yep, basically just starting the left and working your way to the right. You'll get all your like terms that way. So it's kind of nice. All right, let's see. The arc of a ball that's thrown underhand can be modeled by the equation x squared plus 4x plus 7. Complete the t-chart below for the equation. Okay, so basically just plug the numbers in. Now, there's actually an easier way maybe to do this. I could substitute, okay? Let me show you a couple of options you got here, because it's always good to have extra options. I could take this, and every place that I see an x, just plug a negative 1 in. So I'm like, all right, so negative 1 squared plus 4 times negative 1 plus 7. Okay, I can get my answer. Plug in my y. And I could do this for each one of my... Yeah, I'm not showing... I'll show the shortcut in a minute. Yep. And then you're like, why are you assuming that's 2? Well, because it looks like it's going down by 1. Well, what if I want to get all the answers at once? Like, you can do that? Yes. If I hit y equals, and I type the equation in, so x squared plus 4x plus 7. Okay. Now, I could hit graph. That's not going to help me as much. If I hit second graph, the table comes up, and you will be amazed. Oh, Hardy did a bonehead. Now, here's the assumption I made that was boneheaded. We had done negative 1, we got 4. Okay, there it is. Negative 2, we got 3. Okay, there it is. Now, I looked at this like it was a line. Because if you look at it like a line, you'd think, oh, well, 2 would be the next thing. But remember, squared are those U-shaped things called parabolas. And if that's true, I should get something that reflects. So I'm like, okay, well, I copied that from there. Let me look at the graph. Yep, there it is. Looks like a U shape. So then all I got to do for the next one is plot points. Negative 1, 4. Negative 2, 3. Negative 3, 4. Draw my picture. Got to be accurate. I can't just put up the y equals and just quick sketch something. I'm going to be looking for points. If these points match, sweet. Okay, we'll be good to go. Next page. All right. The graph given shows the downward movement of a person jumping on a trampoline. Use it to answer the following questions. Okay, circle one. Is this point, because we're always looking at the vertex, a maximum or a min? Min, because it's at the bottom. Okay. Yep, max is going to be at the top. My vertex is going to be wherever my max or my min's found. So right to down to would be 2, negative 2. And that's a point. It's not slope. Okay, don't make it a fraction. It's just a coordinate point. So we put that there. Yep. And then for my y-intercept, here's my y-axis. Here's where my graph overlaps. I didn't go left or right any, so my x value is 0. But then I went up 2. So I just took the information from the graph they gave me. I didn't even have to figure out how to graph it. That's kind of nice. I like that. So then, oh gracious, the closest thing to an essay question we see. In your own words, describe how the graph of y equals 6x squared and y equals negative 1/2 x squared are different in 2 separate ways. Well, if we're not sure, the best option... Oh, wait, oh.
Do we have anything on our funnel like this? Written word? Not written word, but like...
I have never had a messed up calculator on here. All right, let's start that over and see what happens. So here, I'm going to type both of these in so I can see what they look like. And I'll use negative 0.5 for my x squared. You could type the other end. Now I look at this. What are the two main things that you notice? Yep. One opens up. One opens down. Okay. Which one opens up? The 6x squared does, and I need to make note of that. And then the narrow one, which one is the narrow one? Yeah, and that's kind of weird. The narrow one is the 6x squared, and the wide one is the negative 1/2, because as that value in front of x squared gets bigger, it makes my graph skinnier. And as my value gets smaller or fractional, it makes it get fatter or wider. So I'd be looking for something like that. It doesn't have to be like a paragraph or a topic sentence and a conclusion or anything. As long as I can see that you worked at it and kind of looked at it to see how it worked, I'm fine with this. So let me shrink that back down for a minute.
Negative 1/2 x cubed.
Yep, negative 1/2 x squared. So find the coordinates of the vertex. Okay. Whenever I'm looking for my vertex, I'm going to find all my information right in here. Remember though, for the x value, it switches signs. So I see -4, that becomes positive. I see +1 out here, that stays positive. Okay. So we always switch the x sign. So if I'd have seen a plus in the parentheses, I'd have made it negative. But whatever's out here, I leave the sign alone. So like here, yeah, because this is my x value of my vertex. I'm just switching the sign. So I saw -4, I'm going to make it positive.
Can I go to the bathroom real quick? Thank you.
So then, factor by special case. Now some of you struggled a little bit with this one. What can I times by itself to get 16? Okay, 4.
47.
Okay, so 4 goes first. And since it was x squared, I take the variable with it. And right, since I times 7 by itself to get 49, you got the chart if you need it.
One's going to be 5 and one's going to be negative.
Right, since I'm multiplying to get a negative 49, I have to have one of each sign. It doesn't matter the order. If you did the negative first and then the positive, that'd be fine. But that's all I got to do. There's no real other way to do this. You've got to kind of fight through it as far as this one goes. And then the other one's nice. It's factored already. So your only job is to set each set of parentheses, each quantity equal to 0, and solve for x. So I'm going to add the 3 and divide by 2. Or if you like the decimals better, if you do it in the calculator, that's okay. And then minus the 2 here, and I get my second answer. So if it's already factored for you, don't make it harder than it needs to be. Don't go with the IDK or the question mark or any other interesting, funny drawings you just happen to put in there. Just set them equal to 0 and go. And we're to the last page. Factor and solve. The diamond. All right, multiply to negative 35. Add to negative 2. And right, you can look on your chart, you can play with the calculator, but yep, and here's what I know. I know with it being multiplied to a negative, one's a negative and one's a positive. I also know that when I add them, I'm going to get a negative, so the negative number has to be the bigger number. And I'm looking for two numbers that multiply to 35 that are 2 apart, which is 7 and 5. So for the factoring part, I just take those two values and plug them in here with x. So negative 7 and positive 5. And then just like we just did on the last problem, take each set of parentheses, each quantity, set them equal to 0, and solve them. Boom. Boom. So, again, nothing too terribly awful. So, let's bump up a little. Oh, the quadratic formula. Okay, the formula will be there for you. A is 4. B is negative 4. If there's a minus there, you've got to take it. C is negative 15. Now remember what we talked about before. We talked about do this part first, then I can deal with all the other junk. So when I'm doing this, all right, let's get out of there. So I've got, and in parentheses, just like it is there, b squared minus 4 times a times c, which is negative 15. You know, I should be better about that and make sure I do. A. That's better. Good lesson. I should use my parentheses. So I get that, but then again, I'm taking the square root of it. So the square root of 256 is 16. So here's what I've come to at this point. All of this stuff equals 16. Okay? It says negative b, the opposite of b. So if b is negative 4, that's positive.
Wait, how do you put plus or minus?
We don't. We're going to do them separately. And then it's 2 times a, or 2 times 4. So I go, okay, so 4 plus or minus 16 over 8. Here's the part where we got to do a little work because the calculator doesn't like doing all this stuff at once. I'm going to do the 4 plus 16 up here. I'm going to do the 4 minus 16 down here. And then I'm just going to either let the calculator do it or I'll do it in my head or whatever it happens to be. And if you get decimals, that's okay. 2.5, 4 minus 16. Got to have the parentheses or I will not get the right answer. Negative 1.5. And I'm done. So again, no biggie. Now that's the long one of the group. The shorter one's coming here, the discriminant. It's just the inside part, just the b squared minus 4ac, no square root. But one issue, be careful. You have to have equals 0 before you can start. So how do I get that 4 out of there? Okay, we're going to minus that 4.
Yeah.
And if I forget to do that, I'm not going to get the right answer because my c value is going to be wrong. Always got to be an equals 0 with the quadratic formula or the discriminant. But now I can get my a and my b and my c and plug them into the formula. So b squared minus 4 times a times c. So let's see here. What do we get? Negative 8 squared minus 4 times 2 times 6. 16. And that's it. Don't make life complicated. And finally, oh, back to the data. All right, histogram. The data below shows the number of hours per week a group of students spent watching television. Make a histogram to represent the data. Okay, they're even nice and make this for me. I don't have to worry about it. It's from 0 to 5. My frequency is 6. I'm basically just making bars that represent the lengths of each of these. And I'm set. Don't have to find the mean, the median, the mode, any of that stuff. Now, will that be on the other one? Maybe.
Maybe.
But for this one, no. So And that's about it. So again, this is basically, there will be 25 questions on the short answer part of the final. It's very similar to things like what you're seeing here. Tomorrow we're going to start the multiple choice part, except I've eliminated the multiple choices, so we can actually work through them. But we'll spend Thursday and Friday doing that, and then we'll take any other questions you've got next week.